Question number 18. For what value of lambda is the function defined by f of x lambda x square minus 2x if x less than equal to 0, for x plus 1 if x greater than 0, continuous at x equal to 0. This is the first question. For it's already given that if this function is continuous at x equal to 0, then find the value of lambda. This is the first question. And the second part, what about the continuity at x equal to 1? Check it, is it continuous or discontinuous at x equal to 1. First we have to it's already given that it is continuous at x equal to 0. Find the value of lambda. This is the first question, first part of the question. First let's write the function, the given function. The given function is, this is question number 18. The given function, that is f of x is equal to lambda x square minus 2x if x less than equal to 0, for x plus 1 if x greater than 0. It's already continuous at x equal to 0. It is continuous at x equal to 0. What is the condition? That is limit x tends to f of f left hand side of f left hand side of 0 is equal to limit right hand side of fx is equal to f of 0. This is the condition. Because it's a continuous, therefore it is a equal. So first let's find this all the number. Now for left hand limit and right hand limit, and f of 0, we have to find a, using this we have to find the value of lambda. So first let's find the left hand limit. Limit x tends to 0 minus f of x is equal to limit x tends to 0 minus, which is less than 0. Left side of 0 means less than 0. This will be lambda x square minus 2x. So this is the, now instead of x, put it, instead of x, left hand side of limit, so instead of x we have to put it 0. So it will be 0 lambda 0 minus 2 into 0 0, so that's equal to 0. Now right hand limit, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus f of x. Which one is the function? This is the function greater than 0. This is the function, that is 4x plus 1. Now it will give the, instead of x it will be 0, 4 into 0 plus 1, so it will give 0 plus 1 equal to 1. Now f of 0, f of 0 equal to, the function is this one, x equal to 0, that is lambda 0 minus 2 into 0, that is lambda 0 minus 0, that is equal to 0. So left hand limit, right hand limit, that's limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. So this give left hand limit gives a 0, right hand gives leave a 1, and f of 0 gives the 0. So there is no value of, there is no lambda, so which is not possible, which is not possible, which is not possible, which is not possible. So there is no value of lambda at x equal to 0. There is no value of lambda at x equal to 0. Now we have to check it, is it continuous at x equal to, that is 1. So at equal to 1, see which one will be the function, whichever the number, the x is greater than 0, everything will be this function. So this is the function, we have to check it at x equal to 1. So at x equal to 1, fx is 4x plus 1. So f of 1 is equal to 4 into 1 plus 1, that is 4 plus 1, that is equal to 5. Now we need a limit x tends to, not to check the right hand limit and a right hand limit because we have only one function. So x tends to 1 f of x. So it will be limit x tends to 1. Which one is the function? This is the function 4x plus 1. So it will give 4 into 1 plus 1, that is 4 plus 1, that is equal to 5. So it is continuous at x equal to 1. It is continuous at x equal to 1. So now question number, next question. That is question number 19. Show that a function defined by g x is equal to x minus this is greatest function of a greatest integer. X is discontinuous at all integral point where this box x denotes the greatest integer less than equal to x. Means first we have to, this already mentioned that it is a discontinuous function. In the previous question we have to check it, is it continuous or discontinuous, because we don't know it. Here already mentioned that it is a discontinuous, just we have to prove that it is a discontinuous. Answer is already given, only we have to prove that it is a discontinuous function. Question number 19. G of x is given equal to x minus greatest integer of x. Now what is the greatest integer? Greatest integer means if the number, this is the symbol of greatest, okay, this is the greatest integer, that is greatest integer 1.25. It will give the integer how much? 1. If it is 2.65, it will give 2. This is the greatest integer. So this is the greatest integer, only it gives the integer, not the others number. After the decimal, that number is eliminated, that is called the greatest integer. Now here is a function, here also function. They did not mention any function, they did not mention any point at which point it is continuous and at which point it is not means in the previous question the point is already mentioned, that here the point is doesn't mention it, so we have to take any point. So let's take it as a end. So at x equal to n, so it will be here g of n is equal to, instead of x it will be n minus greatest integer of n. So it will give n only, so n minus n, greatest integer means integer of n. So it will be 0. Now left hand limit x tends to n minus f of x is equal to limit x tends to n minus f of x, that is x minus. Now see from here if we reduce 1 means less than, approach through the negative, so it will be reduced, because if we have here the point here, that is the, we are going to for the, let's take 2 from this side, it will be 2 plus h something, here it will give 2 minus h. If you subtract something from the 2, it will should give the 1 point something, so it's always reduces by 1. How much it reduces by 1? So here it will be n minus 1. So now this will give the n, this will give the n minus 1. So that is n minus n plus 1. So that's equal to 1. Right hand limit n tends to n plus f of x is equal to limit x tends to n plus x minus x. So this is limit x tends to n plus n minus n. Here see it will approach to the right side, so it will increase something, that is it's 2 plus something or 2 plus 0.009, but the integer will remain the 2, so the integer will remain the n. sorry, it will be not, this will be eliminate, so it will give 0. Right hand side equal to 0 and left hand side equal to 1. So these are not equal, so it is a discontinuous function. So limit x tends to n plus f of x is not equal to limit x tends to n minus f of x. Therefore it is discontinuous, it is discontinuous. Question number 20, is the function defined by f of x equal to x square minus sin x plus 5 continuous at x equal to pi? We have to check it, is it continuous at x equal to pi, the given function. Question number 20, f of x is equal to x square minus sin x plus 5. We are going to check at x equal to pi, at x equal to pi. So let's find the f of pi. F of pi is equal to, instead of x, we will be pi square minus sin pi plus 5. Pi square will remain the pi square minus sin, value of sin pi is 0 plus 5. So that is pi square minus pi square plus 5. Now left hand limit, limit x tends to pi minus f of x, left hand side of the pi. So how much we are going to deduct, reduce, you don't know. So we are going to take x tends to pi minus h. So f of x will be, that is x square minus sin x plus 5. Instead of x, now it will replace with pi minus h. So limit h tends to 0, pi minus h square minus pi minus h square, pi minus h whole square minus sin pi minus h plus 5. Now instead of h, we are going to put 0. So pi minus 0 whole square minus sin pi minus 0 plus 5. So that is pi square minus sin pi plus 5. Value of sin pi is 0. Pi square minus 0 plus 5, that is pi square plus 5. Or this is left hand limit. Now right hand limit. Limit x tends to pi plus f of x is equal to limit x tends to pi plus h x square minus sin x plus 5. So it will be limit x tends to, now it's pi, now h tends to 0. Instead of x, it will be pi plus h whole square sin pi, sin, that is pi plus h plus 5. So that's, instead of h, it will be 0. So pi plus 0 h square minus sin pi plus 0 plus 5. So that is pi square minus sin pi plus 5. That is pi square minus sin, value of sin pi is 0 plus 5. That is pi square plus 5. So these two are equal. So these three are equal. This value of, this is value of pi, f of pi, this is left hand limit, and this is right hand limit. All these are equal. That is, it is a continuous. Limit x tends to pi plus f of x is equal to limit x tends to pi minus f of x is equal to f of pi. Therefore it is continuous. Question number 21. Discuss the continuity of the following function sin f of x, that is sin x plus cos x, b f of x sin x minus cos x, c f of x, that is sin x into cos x. We have to check it, is it continuous, or is we have to check the continuity of this function. Question number 21. The function is given. Question number 21a. f of x is equal to sin x plus cos x. Here they did not give any point at which we have to find. So we are going to consider it as, because it's not possible to find each and every point is it continuous or not, because there are lots of points. So we are going to consider only at c, at x equal to c. So the f of c will be equal to, instead of x it will be c, so sin c plus cos c. Now left hand limit x tends to c minus f of x. Now it will limit x tends to c minus, means c minus h. The function is sin x plus cos x. Now the second step, now limit h tends to 0. Instead of x it will be replaced by c minus h. So sin c minus h plus cos c minus h. Now, since x tends to 0, h tends to 0, thus every h will be 0. So it will give sin c minus 0 plus cos c minus 0. So it will be sin c plus cos c. Now this is left hand limit. Now for the right hand limit x tends to c plus f of x is equal to limit x tends to c plus h. The function will remain the same, sin x plus cos x. So instead of x it will be c plus h. Limit as h tends to 0, sin c plus h plus cos c plus h. So it will, instead of h it will be 0, so sin c plus 0 plus cos c plus 0. So it will be sin c plus cos c. See, everywhere we got the sin c plus cos c, here also sin c plus cos c, here also sin c plus cos c. That is left hand limit equal to right hand limit equal to f of c. So limit x tends to c plus f of x is equal to limit x tends to c minus f of x is equal to f of c. Therefore it is continuous. This is the addition. The Roman number 2, that is a subtraction. So Roman number 2, that is b. B is equal to, same, instead of x, instead of plus, now it will be replaced by minus, only that much different. Sin x minus cos x. So we are going to find at x equal to c, because they did not mention any specific point. So we were going to find second, is it continuity at x equal to c. So f of c will be, instead of x it will be replaced by c. So sin c minus cos c. Now it will be sin c minus cos c. This is a function f of c complete. Now left hand limit x tends to c minus f of x is equal to limit x tends to c minus h, because we are approaching through the left hand side. So therefore c minus h f of x, that is sin x minus cos x. Now limit now h tends to 0, instead of x it will be replaced with c minus h, sin c minus h minus cos c minus h. Now instead of h it will be 0, because h tends to 0, sin c minus 0 minus cos c minus 0. So that is sin c minus cos c. Limit, now right hand limit x tends to c plus f of x is equal to limit x tends to c plus h, that is right hand side of h or c. Function will remain the same, sin x minus cos x. Now instead of x it will be replaced with c plus h, that is limit x h tends to 0 sin c plus h minus cos c plus h. Now instead of h it will be 0 because h tends to 0 sin c plus 0 minus cos c plus 0. So that is sin c minus cos c. These three are equal. F of c is equal to left hand limit and the right hand limit. Here also sin c minus cos c, here also sin c minus cos c, here also sin c minus cos c. All these three are equal, therefore it is a continuous. There is limit, left hand limit x tends to c minus f of x is equal to limit x tends to c plus f of x is equal to f of c. Therefore it is continuous function. Now it's for the multiplication. It's question number C. That's the multiplication. C, that is f of x is equal to sin x into cos x. That is now at x equal to c, at x equal to c. So it will be f of c is equal to sin c cos c. So first left hand limit x tends to c minus f of x is equal to limit x tends to c minus h f of x, that is sin x cos x. So it will be limit that h tends to 0 sin c minus h cos c minus h. So instead of h it will be 0 sin c minus 0 cos c minus 0. So it will give sin c cos c. Now right hand limit x tends to c plus f of x is equal to limit x tends to c plus h f of x, that is sin x into cos x. Instead of x, limit h tends to 0 sin c plus h cos c plus h. So limit h tends to 0 that is sin, sorry, h is not required anymore, sin c plus 0 cos c plus 0. So it will be equal to sin c into cos c. C left and right hand limit we got sin c cos c, left hand limit sin c cos c, f of c sin c cos c. These three are equal, therefore it is a continuous. So limit x tends to c minus f of x is equal to limit x tends to c plus f of x equal to f of c. Therefore it is continuous. (22) Discuss the continuity of cosine, that is cos secant, cosine, cosecant, sec, cotangent. That is cos, cosec, sec or cot. Function means we have to check the is it continuous, continuity of, we have to check the continuity of that is cosine or cosine, cosecant, sec and cotangent function. So the function is let's for solving it, I need the sin x cos equal to, that is sin x. Why? Because sin, reciprocal of sin is sin cosec, because I need a cosec, that's why I'll find a check it for the sin, is it continuous, continuity of the sin at x equal to c. So f of c is equal to f of sine c. Left hand limit x tends to c minus f of x is equal to limit x tends to c minus h, or f of x, that is sine x. Now limit h tends to 0 sine c minus h, sine c minus 0, that is sine c. Right hand limit, this is left hand limit. Right hand limit x tends to c plus f of x is equal to limit x tends to c plus h sine x. Limit h tends to 0 sine c plus h, it will give sine c plus 0, that is sine c. So sine c is sine is continuous. Right hand limit, left hand limit and f of c are same. So limit x tends to c minus f of x is equal to limit x tends to c plus f of x is equal to f of c. So it is continuous. It is continuous. Now let's check for the cos, then we will do it together all. The reciprocal part we will do together. So for now let's find the, that is continuity of the cos, because in the cot also we have the relation with the sine and cos, that is cos by sine. So if we find the, check the continuity of sine and cos, then we can find all the others or all the other trigonometric functions. Now let's find for the f of x equal to cos. So it is also at x equal to c. So f of c is equal to cos c. Now left hand limit, limit x tends to c minus f of x is equal to limit x tends to c minus h, the function is cos x. Limit h tends to 0 cos c minus h. Now it will be cos c minus 0. So that is cos c. Now right hand limit, limit x tends to c plus f of x is equal to limit x tends to c plus h f of x. Instead of f of x, it will be the function cos x. So it will give limit h tends to 0 cos c plus h. Now limit cos c plus 0. So that is cos c. Right hand limit cos c, left hand limit cos c, f of c cos c. So these three are equal. Limit x tends to c plus f of x is equal to limit x tends to c minus f of x equal to f of c. Therefore it is continuous. It is continuous. So we got the sine and we got the cos. Now we are going to find the cosec. So for the cosec, and we know the cosec is the reciprocal of the sine. Cosec x equal to, I can write reciprocal of sine x. So sine is continuous and sine is only the value when it is not continuous, the except means which the value will not continuous when the value of, because it cannot be not defined. If the value of sine x becomes 0, then it is not defined, because 1 by 0 is not defined. So we cannot take that number, only we have to eliminate that number. So when the sine x is 0, when it is a n pi. So this is the continuous. Everywhere it will be continuous except at that point where the sine gives the 0. When the sine gives 0, when the n pi. So cosec is continuous. Cosec x is continuous for all value of x. All value of x except means excluding x equal to n pi. Excluding x equal to n pi, the rest of the value it will be the continuous. Now for the sec x, sec x is reciprocal 1 by cos x. All the function of will be the continuous x except when we have to exclude the part when cos 0. When is the cos 0? Cos is 0 at 2n plus 1 pi by 2. So sec x is continuous for all value of x except that is x equal to 2n plus 1 pi by 2. Cot x we know that is cot x is cos by sine, cos x divided by sin x, where the sine is discontinuous. When the sine this will give the 0, the same will the cosec x. So this cot we can find for the tan also in this way. Cot x is continuous for all the value of x except where the sign will be 0 n pi, except x equal to n